Now to the extraordinary images tonight, the scare for visitors at Yellowstone National Park, the very close call with a geyser raining down rock and debris.
Yellowstone, famous for its geysers, hot springs, and awe-inspiring landscapes, is one of America's most beloved national parks. But underneath the beauty, something ancient and powerful is shifting. Recent satellite data and GPS monitoring have revealed a disturbing trend. A dome-shaped uplift is forming and accelerating on Yellowstone's west rim. It's subtle, it's slow, but it's steady. And it may be more dangerous than it looks. Could this be a sign of something building beneath the surface? A pressure cooker reawakening after centuries of slumber. In today's video, we dive into what this uplift means, why scientists are sounding the alarm, and how it ties into the supervolcano that lies hidden beneath Yellowstone's surface. Hit that like button, subscribe for more earth-breaking stories, and let's head straight into the ground beneath our feet. Dome-shaped uplift detected. What does it mean? In early 2025, scientists from the Yellowstone Volcano Observatory, YVO, detected unusual readings from GPS monitoring stations located near the West Rim region of Yellowstone National Park. These stations, which had shown only negligible movement for over a decade, began rising at a measurable rate, initially by fractions of a millimeter per week, and then more steadily over time. By March 2025, satellite-based INSAR, interferometric synthetic aperture radar, confirmed the suspicions. A massive dome-shaped uplift was forming beneath the surface. The deformation resembled a slow, shallow inflation, like a balloon being filled from below. In some areas, vertical displacement reached nearly 2 inches since mid-2024, accompanied by subtle lateral expansion. Perhaps more alarming, a distinct tilt was detected across a roughly 15 square kilometer swath, suggesting the uplift was not symmetrical and could be concentrating strain along a weak geological boundary. Geologically, the shape of the uplift is textbook, a convex bulge indicative of subsurface pressure, usually caused by either magma accumulation or the migration of pressurized hydrothermal fluids. YVO researchers began to correlate this dome formation with minor tremors recorded in nearby seismic stations, many of which clustered tightly around the uplifted area. Some quakes were so faint they could not be felt by humans, yet they revealed critical information, showing that the rock beneath was fracturing, possibly in response to internal pressure. What unsettled geologists most, however, was the location. The west rim of the Yellowstone caldera has historically been one of the most stable and quiet sectors of the entire park. Unlike the Norris Geyser Basin or the Yellowstone Lake region, which regularly exhibit hydrothermal activity and minor seismicity, the West Rim has remained largely uneventful since the early 2000s. The last time a similar pattern of uplift was observed here, it resulted in years of scientific debate and concern, but ultimately settled back down. This time, however, the uplift appears to be growing faster, spreading wider, and is accompanied by more complex data patterns. The soil in some surface locations has also shown signs of warming. Infrared scans taken by low-flying aircraft showed slight increases in ground temperature above the uplift, though still within natural limits. Vegetation stress was observed in isolated patches, and animal movement patterns in the region began shifting as herds avoided certain geothermal zones. Together, these findings paint a picture of a geologic system in transition. Whether that transition leads to a new equilibrium or something more dramatic remains the key question facing researchers today. As the uplift continues to evolve, scientists are ramping up efforts to monitor deformation in real time. hoping to determine whether this is merely a seasonal episode or the prelude to a larger geological shift. What's fueling the uplift? Magma, water, or something worse? Geologists currently propose two primary mechanisms that may be responsible for the observed dome-shaped uplift at Yellowstone's west rim. The first is the intrusion of magma. In this process, molten rock slowly rises from deeper regions of the mantle into shallower chambers just beneath the surface. As this material accumulates, it displaces the overlying crust and causes the land to deform outward and upward. This magma intrusion generates increased ground pressure and often corresponds with thermal anomalies and subtle seismic activity. The second possibility involves the accumulation of pressurized hydrothermal fluids, essentially superheated water and volatile gases that travel through networks of fractured rock. These fluids can become trapped in impermeable zones, where they build up significant pressure over time. When the pressure becomes great enough, it can physically lift the ground, forming a dome-like structure similar to those produced by magma, but often accompanied by unique gas signatures. While either mechanism could theoretically explain the current uplift, researchers believe there is more to the story. The combination of increasing ground deformation, minor earthquake swarms, and unusual behavior in nearby geysers points toward a more complex interaction between thermal and magmatic systems. Data from aerial thermal imaging show a measurable rise in subsurface temperatures, suggesting heat is moving closer to the surface. Simultaneously, ground-level gas sensors have detected a spike in carbon dioxide and sulfur dioxide emissions, gases commonly associated with volcanic processes. These observations raise a troubling possibility that Yellowstone is undergoing the early stages of a magma recharge event. This term refers to the gradual influx of molten rock into existing magma chambers, which increases both temperature and pressure in the surrounding geology. Such a recharge does not necessarily signal an imminent eruption, but it does indicate that the supervolcano's deep plumbing is becoming more active. Researchers emphasize that while this uplift is not immediately dangerous, it is a reminder that Yellowstone is not a dormant relic. It is a living geological system, one that occasionally shifts, breathes, and reminds us of the immense forces moving beneath the Earth's crust. Ongoing monitoring will be crucial in determining whether this is a temporary anomaly or the beginning of a more significant phase in Yellowstone's volcanic evolution. Why the West Rim matters. The west rim of the Yellowstone caldera holds exceptional geologic significance because it overlays a series of intersecting fault zones and magma conduits that form part of the broader volcanic plumbing system. Historically, this region has been one of the most stable and least active sectors of the caldera complex, exhibiting little of the hydrothermal variability or earthquake activity seen in zones like Norris Geyser Basin. However, that long-standing quiet is precisely what makes this new behavior so noteworthy and so concerning to experts. The nature of the uplift occurring here sets it apart from Yellowstone's typical background movement. Many parts of the caldera exhibit seasonal inflation and deflation patterns, often referred to as the park breathing, due to snowmelt infiltration, changes in groundwater levels, and weather-related fluid migration. But this current event is different in both geometry and behavior. Instead of broad, low-amplitude changes across large regions, the West Rim is exhibiting a focused, asymmetric dome-shaped bulge. The tilt measurements show directional strain accumulation, which suggests a mechanical driver, such as a rising pocket of magma or steam pressure being trapped beneath a rock barrier. Seismologists and geophysicists are especially worried that this uplift could be forming along a pre-existing structural weakness, an ancient fracture line that has remained dormant for centuries. If pressurized fluids or magma are indeed infiltrating such a zone, it could create a scenario where the crust suddenly gives way, forming a vent or fissure. This type of localized failure is the first stage in a chain of events that could escalate to hydrothermal eruptions or, though far less likely, a magmatic eruption. What complicates the analysis is the relatively limited baseline data for this specific part of the caldera. Because the West Rim has not shown prior significant unrest in modern times, fewer permanent instruments were deployed there. As a result, geologists are now racing to install more monitoring equipment, including tilt meters, temperature probes, and high-frequency seismic arrays, to understand what exactly is occurring beneath the surface. In summary, the activity at the West Rim is not just a geological oddity, it's a signal that the park's most stable area may no longer be immune to change. Whether it culminates in dramatic surface activity or simply stabilizes over time, this uplift underscores the need for vigilance, preparedness, and continued investment in scientific observation. Yellowstone is a sleeping giant, and its quietest corners may be where the next chapters of its story begin. The bigger picture: is the supervolcano waking up? The Yellowstone supervolcano has erupted 3 times over the past 2.1 million years, each time with catastrophic global consequences. The most recent of these occurred approximately 640,000 years ago, ejecting over 1,000 cubic kilometers of material into the atmosphere and leaving behind the massive Yellowstone caldera that now shapes the park's iconic landscape. Since that cataclysmic event, the volcanic system has gone through cycles of dormancy and reawakening, characterized by phases of uplift and subsidence. While most of these changes have been relatively harmless, recent developments suggest a more complex and potentially concerning shift in the caldera's behavior. In recent years, geologists have observed a series of evolving indicators that suggest the system may be entering a new phase of activity. These include noticeable increases in ground deformation, such as measurable changes in elevation across certain regions of the caldera, particularly around the West Rim. Simultaneously, hydrothermal activity has intensified, with geysers and hot springs showing more erratic patterns of eruption and flow. The composition of volcanic gases venting from the ground has also changed, with rising levels of carbon dioxide and sulfur dioxide, both key indicators of magmatic movement. Furthermore, clusters of minor earthquakes have been recorded, often too small to be felt on the surface, but significant in their implications. These developments together paint the picture of a magma system that is not simply dormant, but actively evolving. What is clear, however, is that the Yellowstone system is not asleep, it is stirring. The ongoing uplift along the West Rim may be nature's way of shifting beneath its crust, testing boundaries and relieving pressure. But it is also a reminder that beneath the serene beauty of Yellowstone lies one of the most powerful volcanic systems on Earth. Understanding this system's behavior is crucial, not just for scientists, but for everyone living within reach of its vast and ancient reach. How scientists are responding. The United States Geological Survey, USGS, and the Yellowstone Volcano Observatory, YVO, have significantly ramped up their efforts to monitor the ongoing uplift and its associated geological phenomena. Scientists understand that the early detection of changes, however minor, can make a profound difference in risk assessment and public preparedness. One of the first measures taken was the deployment of expanded real-time GPS arrays across and around the West Rim. These devices provide continuous data on vertical and horizontal ground movement, enabling scientists to detect even the smallest changes in elevation or surface shift. The data is transmitted in real time to centralized monitoring stations, allowing near-instant updates when deviations occur. To complement GPS readings, the team is utilizing INSAR satellite imaging, a remote sensing technology that uses radar signals to map surface deformation with sub-centimeter precision. These satellite passes provide broad coverage of the park and can detect both symmetrical and asymmetrical patterns of uplift or subsidence over time. With these high-resolution images, geologists can better understand how and where the ground is moving and how fast. Adding to this multifaceted strategy, Scientists have deployed drone-mounted spectrometers and hyperspectral imaging equipment. These aerial tools fly over geyser basins, fault zones, and uplift areas, capturing thermal and chemical signatures from above. The data they collect helps scientists detect temperature shifts, new steam vents, or chemical anomalies in water sources, early warning signs of subterranean heating or fluid migration. In response to the dome-shaped uplift, the USGS has classified the region under a Level 1 notice of volcanic unrest. This is the lowest tier in the 4-level volcano alert system, but still signals that something abnormal is occurring beneath Yellowstone. No evacuation orders or public warnings have been issued at this stage, but the classification mandates continuous monitoring and the readiness to escalate communication should conditions worsen. Behind the scenes, interagency coordination is intensifying. Emergency management teams, local authorities, and federal partners are being briefed on possible scenarios. Contingency plans for road closures, restricted park access, and public safety announcements are being reviewed. Educational outreach is also a key part of the response. Scientists are holding press briefings, publishing open data summaries, and collaborating with schools and local communities to share knowledge and reduce panic. In short, Yellowstone is under a microscope. Every tremor, every gas bubble, and every inch of uplift is being scrutinized with the world's most advanced tools. While there is no immediate danger, the scientific community remains vigilant, knowing that in a place like Yellowstone, change can be slow, but it can also be sudden. Should we be worried? That's the million-dollar question, and one that scientists, emergency managers, and the public grapple with every time Yellowstone exhibits signs of unrest. The most frequently cited consensus among volcanologists is that a catastrophic caldera-forming eruption at Yellowstone is exceedingly rare. Based on geologic records, these massive eruptions occur hundreds of thousands of years apart, and there's currently no evidence to suggest an event of that scale is imminent. However, the absence of a worst-case scenario does not mean there is no risk at all. In fact, smaller but still hazardous events are far more likely to occur. These include hydrothermal explosions, in which superheated water trapped below the surface suddenly flashes to steam, causing localized but violent eruptions of rock and gas. Yellowstone has experienced dozens of such events in its recent geologic past, some of which have left craters over 100 meters wide. These explosions can occur with little or no warning and are particularly dangerous in high-traffic areas of the park. Other plausible scenarios involve localized gas emissions, where increased volcanic degassing can lead to hazardous concentrations of carbon dioxide or sulfur compounds in low-lying areas. These gases can displace oxygen and pose respiratory risks to both humans and animals. There is also the potential for minor lava flows, which, although unlikely to pose a national threat, could devastate parts of the park and disrupt ecosystems and tourism. The real concern, scientists say, lies in the system's inherent unpredictability. Yellowstone is a complex network of faults, magma chambers, hydrothermal conduits, and gas reservoirs. If pressure builds too rapidly in any part of this system without a natural release mechanism, such as venting through geysers or the slow migration of fluids, it could result in sudden surface deformation or eruptive activity. Such events are notoriously difficult to forecast, especially when they fall outside the bounds of typical volcanic behavior. The current uplift at the West Rim is not a definitive predictor of any one outcome, but it does mark a shift in the park's recent geologic behavior. The fact that this activity is occurring in a historically quiet region raises eyebrows and underscores the importance of enhanced monitoring. It is not a doomsday signal, but it is a meaningful anomaly, one that warrants attention, research, and preparedness. It is also a reminder of the sheer dynamism of Earth's crust. Even in the absence of a major eruption, Yellowstone can and does shift in ways that impact both the environment and public safety. The West Rim Dome serves as a wake-up call, a prompt to take Earth's subterranean rhythm seriously and to maintain a level of respectful awareness about the landscape beneath our feet. Nature doesn't always give clear warnings, but it always leaves clues. It's up to us to read them carefully and act with informed caution. So, what do you think about the dome-shaped uplift at Yellowstone's west rim? Is it just another geologic cycle, or a sign of something far more serious? Let us know in the comments. And if you found this video fascinating, hit that like button, subscribe for more Earth mysteries, and share this with someone who needs to know what's moving beneath the surface. Until next time, stay curious and keep your eyes on the ground.